Hey everybody, today's video we're going to look at one of our algebra topics. This is going to be absolute value. You don't need a calculator for this one. All you need is your absolute value note page from your test 1 notes. Alright, so let's start with what we mean by absolute value. So we're going to look at the definition here. We say that the absolute value of a number is its distance from 0 on the number line. When you're thinking about absolute value, you should always be thinking about a number line. And then we use these little vertical bars to let us know that we want to take absolute value. So if we look at our first example, number 1, we want the absolute value of -9. So you want to kind of envision a number line. All right, so we're going to have 0 here in the middle. 2, 3, 4, 5, 6, 7, 8, 9, and we know that -9 is down here 9 units to the left. So what we're really looking at is this distance right here. And we can see that it's 9 units to the left. We don't really care which direction it is. So we would just say that the distance is 9 units. So when we're talking about distance, we're not going to get a negative answer. If I also ask you for the absolute value of +9, it would be the same. The only difference is it's 9 units to the right instead of 9 units to the left. So we call these numbers opposites because they have the same distance. And that also means that they have the same absolute value. So we're not going to get a negative value when we take absolute value. So for number 1, absolute value of -9 will simply be 9. For number 2, we need the absolute value of 20. Since it's already a positive number, we know that it's just going to be 20 units from 0, so the number stays the same. Absolute value from 0 would be 0 units from 0 on the number line, so that would just be 0. And absolute value of 14 is just 14. So we can see for the positive numbers, it's pretty easy. You just leave the number the same. Number 5, we have absolute value of -39. It's going to be 39 units to the left, so we just put 39. Now we're going to start getting into some that are fractions or decimals. You don't have to change from fraction to decimal or decimal to fraction. You can leave the representation the same. So for number 6, we want the absolute value of -8.1, so that distance is just going to be 8.1. We're just going to write that without the negative. Now when we see a fraction, we want to see if it's reduced. So for number 7, we have absolute value of 7/8. 7/8 is already reduced, so my answer is just going to be 7/8. But if I look at number 8, I have the absolute value of -35 divided by 5, and that number can be simplified. We know that 35 divided by 5 is just 7, so we haven't taken the absolute value yet. All we've done is we've cleaned up that fraction a little bit. So now we have the absolute value of -7, which is going to be 7. So once we take the absolute value, notice that we do drop those vertical bars. All right, for number 9, that one can also be simplified. 0 divided by 12 is just 0, and then absolute value of 0 is still 0. Okay, now our last two, we do have some operations. So we do want to simplify first whatever's inside the absolute value symbols. Then when we get it to a single number, we can take the absolute value. So you may remember anytime you minus a negative, we can rewrite that as a positive. So this becomes the absolute value of 7 plus 3, which gives us the absolute value of 10. And then we just take that absolute value to give us 10. On our last example, I'm sorry, I went off the page a little bit there. On our last example, we have a negative and a positive. So when the signs are different, we do take the difference between the numbers. So the difference between 9 and 4 will give us 5. But 9 is bigger than 4, so we keep its sign. So we get the absolute value of -5. Then we take the absolute value of that to get 5.